Hello everyone, good evening. Hello Sanket, hi Neel.
Hi, Shivani.
Thank you for
Hey,
joining us
hello.
today. Hi. Okay, for the audience, thank you very much for joining us this evening. I'm Shivani. I head the marketing team at Coditas and I will be your host for today's webinar on decoding machine learning. Let me give you all a quick introduction of our speakers. Our first speaker for the day is Neel Gala, who is an associate director of technology at Coditas and holds a vast experience working in FMCG, electronic, cosmetic, insurance, security, stock brokerage, and martech domain. Accompanying Neil is Sanket Kelkar, who is a tech lead at Coditas and a solution specialist with 8 plus years of experience in the data space. For those of you who don't know Coditas, we are a UX focused software engineering company based in Pune. We help product companies across the globe in building and running cutting edge digital business models. And we feel extremely proud to share that we are a great place to work. To know us better and for some amazing content, do follow us on our social media channels. We are very active on LinkedIn, Facebook, Twitter, and Instagram. You can also subscribe to our YouTube channel so that you get notified about our next webinar. A final note before we get started, we will be having the question and answer session towards the end of the presentation, so feel free to put your questions in the chat section. That's it from my side. Neil and Sanket, over to you.
Thanks, Shivani, for setting up the context correctly. Thanks everyone, first of all, for joining this. I feel that there is one common love, there's something which brings us together, which is the love for the data. That is something which, to start, and a topic which is decoding machine learning. What we are trying to do over here is we are going to talk about how at Coditas we are leveraging machine learning to help different clients consult them in various domains. Today's agenda is something briefly I will talk about. So we'll talk about introduction, like who are basically going to talk about different use cases, how we are tackling those. Second thing is comparing the different data roles. So there is still ambiguity around different kind of data roles which we have in this industry. So we are going to talk about those. The third one is the business use cases, which we are very proud of, the way we are working at Coditas and how we are trying to use or leverage the machine learning to solve their business problems in different domains. And fourth is something which is like Coditas data vertical, how we are growing and how we are going to basically take it ahead. Going to the next part, which is introduction. So Shivani has already helped us, but Neel Gala, working as associate director in Coditas. I have more than 7 years of experience working in different domains, majorly in like electronic component in FMCG domain. And from the start itself, I have been associated in data science domain. That is something which is my expertise. And here at Coditas, trying to grow the entire vertical, starting with data engineering and the data science as well. Sanket, I would like you to introduce yourself here.
Sure. Thank you, Neil. Good evening, everyone. I'm Sanket Kelkar. I'm tech lead at Coditas, working on Python, SQL, and machine learning. And as Neil said, we are excited to have this session with you all. We love solving the business case studies, and we love solving the problems faced by our customers.
Yeah, thanks for that, Sanket. Unfortunately, Dhimant Gandhi is not here due to medical reasons, but he's again active member of this vertical. Coming to different data roles, so everyone must have heard about data engineers, data scientists, data analysts, but there is still ambiguity or based on different companies, the job description or the way each role is pursued is different. We at Kutas felt that okay, why not basically talk about this as a fundamental thing, the clear distinction between the different roles or the responsibility which comes with that. Starting with, we'll talk about data engineers. So in data engineers, basically we'll talk about four things, which are tasks, technologies, users, and eventually telling you the summary about it. So data engineers, right? The way with the name suggests itself, basically they are the core foundational members of the team in the data vertical. The way we perceive or the ideally the terminology is like the way these guys take the whole and sole responsibility of creating the data pipelines, connecting different data sources coming be it from relational databases or NoSQL or through APIs or from like files. So that this is something basically should is termed as the task for data engineers.
Neil, sorry, we are not able to hear you.
Okay, can you hear me? Yep.
Yes, yes.
Here the technology wise the different technology which are getting used by data engineers is SQL, Python, Spark, in cloud, all the services which are given by AWS, GCP and Azure. And from the big data perspective, so nowadays we know that each and every company has tons of data, but like we don't know that how we can leverage those. But for that we talk about the compute, which is like actually is solved by Azure, AWS and GCP, where we get the scalability and we can leverage the infrastructure which they provide. So because of which in last 10 years or 20 years, this field has basically taken have more traction in terms of now we have more data as well as how we can leverage those data with the help of different compute machines and the advancement in the data science space as well. And the users, so eventually the data which is getting prepared by the data engineering team, getting the data from different data sources, and eventually it will be used by the data science team actually to build the models. And to just to summarize, right? So the whole and sole responsibility for the data engineer is to make sure that creating the right set of data pipelines, understanding the businesses, which are the important data sources, how the data actually comes in a different way, and making sure that it is clean enough or we transform it in a correct way and give it back to the data science team. So this is the whole responsibility with respect to data engineers, where in a similar way for the data scientists, the major task which are involved with them is building the ML models, be it recommendation engines or forecast, doing the sales forecasting engine or creating route optimization, just to name few. But at the end of the day, it depends at like what the actual business needs. So in terms of what is there, we need to align or create the models which are aligned with the business needs, what is the actual business outcome, and work on top of that. And if I speak from a technical perspective, so they need to perform the EDA task or do the feature engineering and doing the feature selection. But the most important thing over here is you can do all these things if you know the domain well or if you know the context, which are the important parameters which are used in that industry or which can be the important features for this model. So to have the right business context is very important for data scientists to build the models to make it very successful, as everyone knows that there are lots of models which are getting built but it doesn't go into production. So this is the most important crux, that at the end of the day, it needs to solve the business problem. So how we can tie the entire activity, create be it in the data engineering space or while doing the data science thing, how we can basically tie the business objectives and use or leverage data engineering and data science together to take it to the next level. In terms of technology, again, SQL is important, or if the data is in a NoSQL way, then we can leverage MongoDB or the other services. Just to name few from the AWS perspective, it is DynamoDB is something which we can use. ML algorithms or deep learning algorithms, the advancement is something which we need to have accustomed to those kind of algorithms we should know, so that we can leverage those algorithms and try to solve the problems of the clients. And again, from the cloud, so there are auto MLs or how we can deploy these models are the important things as well, which we should consider. The users, basically, we need it is an intermediary where basically the data will come from the data engineers, and then it has to be passed to data analyst team. So the three characters which I talked about is data engineers, data scientists, and eventually once the model is running, it is predicting the results, and then it will go to data analyst team who will actually analyze it through different technologies, like how we can understand this data, or what is the actual outcome of this entire activity. So from a user perspective, that the stakeholder for the entire output will be the data analyst team, which will eventually report to C-suite executives from the client, where basically different KPIs or the measuring KPIs will be uh, told by them. From the summary perspective, the data scientists, the whole responsibility of building the models and putting it into production, making it usable, right? Which actually, like, we should the ideal focus should not be like which algorithm uh, we should fit in. The idea should come from like first understanding the business, then eventually based on the use case, like whether we can use supervised, unsupervised algorithms, and then eventually then it will narrow down like which all algorithms we can use, and then trying to do the research based on that and taking it ahead. Now coming to data analyst, again from the task, technologies, and users perspective. So the task is like, now once the data has been prepared, if the models are prepared, and we get the prediction out of it, we need to find the insights, basically whether the operational metrics are going down, or whether we can generate more profits or revenues from a business or from the client perspective are the most important things, because eventually the end goal is to help the company prosper or grow the company in different areas, be it operational or through technology. Basically we'll try to improve those KPIs. And from the technology perspective, here data analyst usually deals with Power BI, Tableau, ClickView, are just few tools to name it. And Excel, and they are very good with Excel and SQL, so that because they need to fetch the data from different data sources to find the insights out of it. And from a user perspective, eventually this data is passed to business user who actually tie it with the business goals, whether their KPIs are improving or not, or if there are operational overheads which they are able to reduce it or not. So just this are named to few of them. From Crux perspective, they take the responsibility of creating the dashboards, which will give the business insights, which can help the executives to take a better decision to take it ahead. Now I will hand it over to Sanket, who will talk about the business use cases.
Sure. Thank you, Neil, for the detailed comparison of the three roles, which are very important: data engineer, data scientist, and data analyst. Good evening, all. I'm here to take this webinar ahead with our business case. So recently, we deployed the ML solution into production for one of our sales and marketing customers. So the next few slides will be based on that project deployment. So we'll talk a bit about the business, like the domain, which is of marketing technology. Plus, we'll talk a little about the technical terms that we have used in this project. So, okay. So just to start, the domain is marketing technology. So marketing technology is the domain in which technology is used to help the marketing team in achieving their goals. Okay. So whenever the marketing technology domain is concerned, there are three important aspects of it. First one is the prospect. Okay. So prospect is a person who is a potential or the existing customer. So we receive all types of calls from agents, from sales representatives trying to sell their product, like credit card, debit card, or some sort of stock recommendation, or some XYZ types of product. So what happens is we become the prospect, and it could be the existing customer as well as the new customer. So the whole agenda is to nurture and retain the existing customers, plus we have to sell to the new customers. Second aspect of marketing technology is an agent. Agent is a sales representative who basically calls you and who tries to sell the product. Okay, and agent basically understands the goal of the company that they are trying to achieve through this marketing technology domain. And the third aspect is a campaign. Campaign could be anything which is aimed at improving the company brand awareness or a social media presence, or it could be about generating more revenues, more sales values, or even it could be about reducing the impact of any negative value as well. So whenever we consider a marketing technology, it is about prospect, agent, and campaign. So we had this problem statement wherein a customer came to us with their unique problem statement. The problem statement was like they had more than 1 lakh or 2 lakhs of prospects. But then what happened was these prospects were not smart enough. Most of the times the prospect had wrong phone number, wrong email ID, or most of the times the prospects were not interested in buying the product or even listening to the proposal. So all that resulted in fewer conversations, and in the end it resulted in fewer conversion. So conversion is again a term which is used to when sale happens. So whenever an agent successfully sells the product to the prospect, that's what we called as a conversion. So the problem statement was there were fewer conversations which resulted in less conversion. So we started with this, and the objective or the end goal for this project was to get more conversion. Okay, how did we get that? Is we can see in the next slide. We used ML supervised as well as unsupervised algorithms, and then we achieved this objective. How did we tackle that? First, we initiated the project. Initiation was about understanding the problem statement. Again, as I said here, the problem was about fewer conversations because the data was not correct. Mostly the prospects they were not interested to buy our product, and then the agent's time was getting wasted on calling the wrong prospects. So this was the problem statement. As soon as we got to know about a problem statement, we asked ourselves two questions. First question is, do we really need an ML solution for this problem or not? Because what happens is machine learning, data science, mostly all these are buzzwords, but then you don't need machine learning for each and every problem. So what happens is whenever you are trying to build any solution, you need to sit back and understand whether the entire solution could be done without ML, like it could be done by building some sort of software or by building some sort of data cleaning activity, just without leveraging any type of ML. Can we handle this problem? If the answer to the first question is yes, the immediate next question is, do we have the right data or not? Because we all know machine learning is about training on the historical data, and then the model tries to predict the unseen data or the newly arrived data. But for that, it needs to have right data in place at the first time. So if the answer to those two questions is yes, then only we have to move ahead. In our case, fortunately, we needed the ML solution for this problem, and we had some sort of right data with us as well. So we went ahead with the third step, which is execute. In execute, what happened is we had the data, but then it was in very heterogeneous data sources. So it was in Excel format, it was in CSV format, it was on some sort of third-party providers. Then it was in MongoDB, it was in PostgreSQL as well. So once you start the ML problem, your 60 to 70% of the time is invested in preparing for the data. So to go ahead with that ideology, we started with execution of this project. So we gathered the data that is needed. We performed the exploratory data analysis or the EDA on that data. To talk in a detail about EDA, we performed outliers detection, we performed missing value imputation, then we performed the multivariate, bivariate, and univariate analysis on our data. We used a lot of charts like box and whisker plot, heat map, tree map, and then we spent quite a good amount of time in understanding the data and whether this data can be passed to our ML model or not. After EDA, we continued with the feature engineering. We had 1 crore observations and 700 features with us. So of course, not all of these 700 features were important to us. That's why we had to do some sort of feature engineering. In feature engineering, we did the encoding, we did the PCA, we did the data was also quite imbalanced, so we applied some balancing techniques as well. Feature selection was again one of the very important points, because again 700 features, not all of them were important, so we applied the feature selection techniques as well. Then once the data was available and it was ready for the ML, we implemented or we executed multiple ML algorithms. Mainly those were classification types. So we implemented multiple classification algorithms on that data. The algorithm that performed well, then we had the hyperparameter tuning on that algorithm. We did some sort of A/B testing as well across the algorithms that were executed. Once we found that we have a sustainable solution on the machine learning side, we decided to go ahead and deploy the solution. Of course, before deployment, multiple rounds of testing happened. We actually connected with the sales agents and we tried to see whether this ML solution is improving their life or not. So we went ahead with the smaller set of agents, and then once we got to know that this is really helping them, we then decided to go ahead and deploy it onto production. So for deployment, we have used the pickle. So we used the pickle.dump as an instance and then loaded it onto AWS S3. So whenever a new record would arrive on S3, our model would get loaded and then it would try to predict on top of the model that is deployed. We also tried to verify with AWS SageMaker as well, and that's how we deployed the model. Once you deploy, it doesn't happen that the model would keep on running extremely well every time. So what happens is, in case of ML, usually once you deploy it, you have to actively monitor it and retrain it. So in our case, this retraining and monitoring happens every week on Saturday. So on Saturday, our models are retrained with the latest data, and then they get hyperparameter tuning again, and then they get self-deployed again on the AWS. Again, on this, we ran multiple feedback loops. We also implemented the champion challenger type of setup, wherein there was a champion model and there were challenger models continuously challenging the champion or the winning model as well. So just a summary point here is that you cannot just deploy the ML model and keep it as it is. You need to actively monitor it and retrain it. And of course, to close the project, we closed with our learnings. Learnings were a lot, mainly on the data preparation point of view, data wrangling point of view. We also learned a lot on the ML and deployment part, and we planned the next steps. So this is how the ideation to deployment happened. Talking about tools and technologies used in this project, on the database, we had the PostgreSQL, which is the AWS RDS, and then the MongoDB. So our source was MongoDB, wherein we used to get semi-structured data in a documented format or a key value pair format. And then our 60 to 70% of the time went in converting the semi-structured format to the structured format. Okay, so we converted from MongoDB to PostgreSQL. There were two important points or factors. Why did we do it? Is because first of all, the MongoDB is our transactional system. So we wanted to keep our ML system away from the transactional system, because our product would connect to MongoDB and then we did not want to overburden it. That's why we thought of creating another database on which ML models would run independently. And of course, the second point was all about the PostgreSQL being the RDBMS or the structured format. It is more suitable for the BI or the ML side. That's why we separated MongoDB and PostgreSQL. As far as programming is taken into consideration, we have heavily used Python and SQL. All the data engineering tasks and methods were almost done in SQL by using joins, aggregations, window functions, and then stored procedures and functions as well. We have created a lot of views as well. So SQL was heavily used on, of course, the PostgreSQL. And then Python was mainly used to perform the EDA, feature engineering and selection, and then the hyperparameter tuning and deployment. So Python and SQL are two most important programming languages that we have used here. On the ML part, we have used logistic, KNN, and random forest and decision tree to predict the pipeline stage of a prospect. So when I say a pipeline stage, It is about in which stage the prospect is, whether it is in interested stage or whether it is in potential buyer stage or whether it is in like he or she has completed the sales stage. So for that we have used the supervised machine learning algorithms. For unsupervised algorithms, we have used k-means, which basically tries to cluster our prospects, and then the defined or specific marketing strategies are applied on those clusters. And then we again try to convert the prospects which are from stage A to final stage, which is our completed sales stage. So for all those things, we have used supervised as well as unsupervised ML algorithms. The deployment happened through AWS S3 and then the pickle files. So what we did was once our model was trained, just after the fit, we did it the pickle.dump, and then the model object was created, and then that model object was put on S3. As soon as a new data arrives, the model gets loaded, and then the new data passes through the model evaluation, and then it gets predicted whether this prospect is about to buy a product or he or she is a potential buyer or etc. So the deployment happened through S3 and pickling. Scheduling is done through AWS batch using the Jenkins containers. So this is the technical details of how we achieved or how we deployed our ML solution into production. So just to summarize, the objective is about getting more conversations and conversions. So as I said, the problem statement was all about agents calling the wrong person or probably calling the person with bad phone number or bad email, wrong phone number, all those things. So the agent's daytime was getting wasted on the unproductive things such as calling the bad person, and that's how the conversion rate was very, very low. So that was the objective, wherein we had to increase the number of conversations and increase the number of conversions. So what happened is our agents received, let's say, 1 lakh prospects, but then that list was not smart enough. That list just had the list of prospects. So agents were really not aware of which prospect to call on priority. So our ML model tried to predict that out of these 1 lakh prospects, these 50 are the customers who are predicted to buy your product. So you have to reach out to them first and you have to follow up them with first. Okay, so that's what our ML model is all about, wherein it tries to predict the outcome or the pipeline stage of a particular prospect, wherein the prospects which are predicted to be the potential customers are called first, rather than the prospects which are very less likely to buy a product. The process is all about implementing the ML solution using the technologies that I just mentioned: Python, SQL, supervised learning, unsupervised learning, and the deployment also. Monitor and retrain. Again, I'm emphasizing on this particular point, wherein you just cannot keep a model deployed on production and let it run on its own, because what happens is as soon as a set of new data is again captured, your deployed model may not run perfectly. So what happens is you need to retrain those models. You need to have some sort of A/B testing and champion challenger type of setup, wherein let's say a logistic regression is a champion model right now, but after 1 month, it might happen that random forest is performing better than the logistic regression. So you need to have all those feedback loops, all those monitoring and retraining setup in place, wherein day in, day out, as soon as a new data arrives, your product is perfectly predicting the outcome. So that's why monitor and retraining is very, very important. So let me talk about the key result. Key result we observed was about 50% more conversations. So we observed that our agents are reaching out to right prospect, wherein of course they are not right then and there only, they are not buying the product, but then at least they are having some healthy conversation. They are getting the follow-up calls via emails, voicemails, or calls. So we could see that there are meaningful conversations going on, and we could see that it went by 50%. And of course, as soon as your conversations move up, there is a high chance of getting converted. So we could see that 30% conversions happened because of the ML deployment, because again, we tried to predict the prospects which are very likely to buy our product over the prospects which are less likely to buy our product. So this is what the overall business case was. Marketing technology was the domain. The objective was about increasing conversion. Process was the ML, and key result was about the 30% gain in the conversion. At this point, I would like Neil to go ahead and talk about this business case, but in a more generalized way. So, Neil, can you take this ahead?
Yeah, sure. Okay. So thanks, Sanket, for that. This is just one of the use case which we have sold, like we have done at Coditas, and so it is something which we are very proud of, right? ML or using data science is very exhaustive process. People think that like it is very easy to create models. So actually, model takes like just 15 to 20 percentage of your entire work. But starting from business requirement, understanding the business, uh, from where you will get the data, different data sources, how you can collate it, how you can put it in a very nice format, like how you can correctly transform the data, then eventually doing the data wrangling part, and then using the models which can be deployed in production and to sustain that, right? That's where the actual exhaustive part comes in, because your data keeps on changing the behavior of your agents, or in any business use case the data will change over the period of time. So how you are ready for those things, how you are retraining or giving the feedback loops to your models are the most important key things which we need to consider. It is very easy to put one model in production, or just to do the testing for the testing purpose, but to sustain that over the period of time, making sure that it is relevant and it is basically helping the business. So that's where, like, how does ML can help in business, right? So first of all, the entire process, it was very exhaustive thing which we started for this particular use case, where it took 8 months to do end-to-end thing. So we started with knowing more about the business, extracting the patterns, knowing what is the domain of the client, understanding the hidden patterns out of it, because you have to get accustomed to the different jargons or different terminologies which we use in those domains, and eventually understanding and taking it as features, and which are understanding which are the important features out of it, plays a very important role, or it plays as a foundational block for your future models. Eventually going, what is the most important thing is, you have to be very customer focused. That was one of the key aspect for us, understanding what customer needs. Like that, in this the same example which Sanket talked about, right? The clear objective was to make more conversion for this client, where because it eventually results in more revenue, more profitability. So here we correctly knew the pain area, or knowing that what was the business objective for the client. Eventually how we can help, like them help the client using the technology, using the machine learning, was a crucial aspect. So that's where we try to understand the pain area of the customer, focusing on those, and making sure that how we can increase the sales, or how we can increase the customer loyalty, so that they can buy this different products from the same client. And that was the basically plan which we went ahead with. Next, 2 points are how you actually plan it, right? There were lots of mistakes which like we have done over the period of time, uh, which eventually learn as and when you understand the business, you understand that domain. Uh, then you try to fit in or leverage the technology, using the machine learning while doing the ETA part. There were lots of POCs or experiments which we did, and then it helps you to actually arrive at one particular solution, or the actual working, where this is the prototype and this is something which we should go ahead with. So it is very important to plan it in that way, and tying it with basically what customer needs is something which is very crucial. And keep on adapting. So as Sanket talked about, like, we keep on retraining our models week on week, to make sure that the models are very relevant to the data which is getting changed each and every week. Because like there are tons of calls which are done by the agents each and every day, So to make sure that the behavioral change over the period of time, so that our models can get tuned according to that, and it can lead to better prospects, so that which can eventually get more conversion. So this is something which we have tried to do. Now, in general, in industry, what we always talk about is there are lots of myth, right? In ML, like everyone talks about, like ML is a magic wand. Like ML can help you to get success, or it can do any wonder. But ML is not a magic wand, right? If you There are lots of pieces which are environmental factor, which are very important for ML to work properly, which are like having the right set of data, doing the right set of analysis on top of that, which feature are important, right? So those are the key areas which are around ML, which helps ML to work in an efficient way. So those are the actual foundational or pillars which we should focus on. Then it will eventually lead to using ML in a right way, which can help to successfully put the ML models in production. Now, whether ML is for all. So there is again a myth that okay, we can use ML everywhere and get the results. It can help to reduce overall losses or increase the profit margins. It can reduce my overall operational cost. But that is not the truth. Whether we should sit back and look at the problem, that whether actually there is a need, we need to justify, we need to be honest with ourselves that whether actually there is a need to use ML, or whether do we have a right set of data to actually put it into ML algorithm so that it can work in an efficient way, or it can actually give or predict the right output. So we need to think from those aspects. We need to be true to those basically foundational things that can actually help us to making the business understand, or the ML which we are using, right? Then it will make sense. Otherwise, you do whatever you want to, but if the data is not correct, uh, if we are not transforming it in a correct way, it is eventually going to fail in production, or when the actual data will come, that it is not going to work, because you don't have a right set of data to work on. Now, like AI is the next big thing, or ML is the next big thing, or it is the only future. The answer is no. Like ML is not the only thing which will go in this industry. There are lots of other aspects, like the product building, the software management, whether the testing part of it. So these aspects are not going to go anywhere. It is going to complement all the aspects which we have in product development. So it is going to work hand in hand, or there will be definitely advancement in this area, but this is not the only thing which is going to get prospered. It has to work in hand, so that the the use case which we talked about, right? The ML actually in product, it is not something which is visible. It works behind the scene, and it helps the actual campaigns to tell the right set of prospect. So even in product, it might not be visible, but it helps as a like in overall product development perspective. So it has to work hand in hand in that case. Now, there is again a term called as like there should not be any human touch, or there should not be anything which can be driven by humans. But at the end of the day, we need to sit with domain experts who are working in the same industry from years, that can actually tell us that which are the important features. If as a data scientist, if we focus only on the algorithms, and if we don't know in that industry which are the important features, or what are the terminologies, or whether it makes sense or not, or whether we should consider those kind of parameters or not, these are very important aspect which won't be told by your ML algorithms. What we need to do is we need to work very closely with the business analyst. We need to work with the clients, and understanding that how it actually functions, how it can help, so that the entire process becomes smoother. We understand that how we can take it ahead, and how we can actually complement with our expertise in technology, in machine learning, and getting the knowledge of business and trying to make the overall project successful. Going to the next thing, like whether like everyone talks about we want to get into machine learning, but if we don't know how to use a SQL, or if we don't know how the data looks like, or how we are going to store it in database, or how we can create the data lake, or how we can actually create a data warehouse, or how we can fetch the data from different data sources, then it is we can't work in silos where we can say that I'm just going to work on model building and the rest of the things will work on its own. We need to do the dirty work as well, where we need to focus on where the data is, how the data looks like, whether it is making sense or not. Getting your hands dirty on different databases, different data sources, understanding it, that is a prime responsibility of data engineers as well as data scientists, so that they have to work very like together to make sure that the end project's delivery becomes smooth. And last is it's true that on all the courses which we do, or there are tons of websites in the internet where it they teaches you to actually how the different algorithm works, or how it takes the input, how you need to do the hyperparameter tuning. But sadly, no one talks about how the data is stored, or everyone gives the data in the CSV format. uh, with this is not how your actually clients will work. Clients will have the data in n number of data sources, or there will be n number of systems where data will reside, where actually as data engineer we need to make sure that we correctly identify those data sources, creating the right set of pipelines, and eventually giving back to data scientists so that they can build the models, and giving back to data analysts who can find the meaningful insights out of it. So, like the common challenge which we have seen with freshers, or the myth which we have in this industry is like CSV is the data source. If I get the data, then I'll be able to work on the model and get it done. But that's not the how the entire thing works. Or if you want to make the entire product successful, you need to think holistically. You need to think from the start, where like again from the business perspective, getting the requirements, understanding what is actually making sense, doing the dirty work, doing the writing SQL queries, getting the data from different data sources, then actually working on the ML models. Uh, Based on our experience, it actually is 15 to 20 percentage of actual model building in terms of the entire project timeline. So most of the time we actually do try to do lots of POCs, doing the EDA work, and making sure that uh, when the actual model deployment, how we can do those model deployments. Now, we have talked about the different business use cases which we have done like in Coditas, how much we are proud about those. Now I will talk about Coditas as a data science vertical. I'm very much sure that like everyone wants to understand that how differently we do it at Coditas, how we are leveraging machine learning and helping the clients. So here we'll talk about certain things. So to start with, we have started this vertical 1.5 year back, and now we are like proud 35-member team who love data. They love to solve the business problems. They want to understand the business, and they want to help with the help of technology. The different technologies which we are using, the cloud service providers which we are using over here. So based on the client requirements, we work on AWS, Azure, and GCP as well, uh, because these are the top three cloud providers which we have. From the programming perspective, again, we use majorly Python, R, SQL, and Golang over here. Most of our clients are in industry, by industry standards, like Python is the go-to language. The reason being Python can be used for web development, it can be used for machine learning. You can create the entire product very quickly. So that because of that, there is a general adoption of Python in the entire industry. But whereas R is something also which we can, if we want to do a quick statistical analysis, is something which we use over here. And SQL as like SQL or NoSQL, where getting the data from different data sources so that we can build those models. Now, talking about different databases, here we use SQL, MySQL, MS SQL, PostgreSQL, Snowflake, SAP HANA, and Oracle, to just name few. No, from NoSQL perspective, we are using MongoDB, AWS, DynamoDB largely. And from the version control perspective, we are using Git, TFS, and SVN. And the methodology which we are actually using over here is agile, because we always believe that we have to fail faster. So we work in a sprint where basically we try to do quick POCs, we try to fail so that we have the quick learnings from those, that which are the areas we shouldn't focus on, and which are the uh, right areas where we need to do more research and try to get the meaningful insights out of it, which can be like actually helpful to the business. And now, in terms of the opportunity, so in the last one year, the growth which we have seen at Coditas is massive, but we always feel it is just one step which we have taken yet. There are tons of opportunities from a growth perspective, and we are open towards learning new things. We are always on the go, that what what is something new which we can learn from a domain perspective and technology perspective. As I'm sure everyone knows that there are lots of advancement which is happening in this space, and also we need to understand the psychology behind how the actual business works. So that is a fun part which everyone at Coditas, especially in the data science vertical, we are very proud of, where we are each and every day we are learning something new. Every day we are trying to learn from technology perspective as well as business, so that it always pushes you or it challenges you, that it doesn't, we don't always sit in the comfort zone. It always put you on your toes, so where you need to always constantly get up to dated with different technologies, different algorithms, what are the advancements which are happening. And also we need to make sure that we understand the business in a right way with the right context, so that we can actually use our expertise and help them. Now, from the opportunities perspective, there's something which again we are very proud of. We are actively hiring across all the levels in the data vertical. So if anyone was interested, the experience level ranges from 0 to 8 or 8 plus as well, where we are looking for people who are passionate about data, who wants to work with businesses, who want to basically work on different problem statements, and eventually having the stronghold in the technical side as well, where different technologies like Python, SQL, machine learning is the bare minimum, is something which we look at. And from a data engineering perspective, again, Spark, Hadoop, or different services on AWS or any of the cloud services, something which we look for. And if you are interested, we would be very happy to see. So you can just shoot an email to Ruchika Pute. She is our HR recruiter. So you can write the subject with the subject like decoding machine learning with your name and position, and we are sure that we'll be able to reply you within 1 or 2 days. Shivani, over to you. Like we can take the questions over here.
Sure, Neil. Yep. Thank you. Thank you for the insightful information. And let's move on to the questions. We have good questions coming in. So to get started, we have first question from Ketan Joshi. Ketan says, "What are the data analyst's role and responsibilities?"
Okay, yeah. So, like as I already taken in the like slides where we talked about different roles, starting with data engineers, data scientist and data analyst. So data analyst primary job responsibility will be understanding, getting the insights out of the data. So the different predictions which we have done by the data scientist based on our models, uh, how you can make sense out of it, how you can tie it to the business objectives, which can be leveraged by executives to take certain decisions at their level, is something will be the primary responsibility. From the roles, from the technical perspective, like using Power BI, Tableau, having hands-on in Excel and SQL is something which is bare minimum you should have for the data analyst role.
All right. Okay. Thank you. Next question we have from Shreya. She's asking, are you currently hiring interns or trainees for roles you are discussing today?
Absolutely. So we are always open to basically we have lots of opportunities which we have within this vertical. So if we have the right set of skill set and right candidate, we are always on the go. So and we are growing immensely with at Coditas. So uh, to answer your question, yes, we are open towards getting the interns or full-time employees as well.
All right. Okay. Next question we have from Sajal asking, what are the growth plans of the data science vertical and Coditas?
Okay, very interesting question because we feel that we have just scratched the surface, to be very honest. So even though we had a very huge year this at Coditas in the data vertical, but there are lots of things which we want to touch in NLP space or in the computer vision. Uh, and even from a domain perspective from the client, so we have very different customers, and as a stockbroker, one of the stockbroker, or uh, in marktech, or even the like in different data spaces in the different domains. But we want to expand the different verticals as well, so that we can help them um, at a domain level, and we want to like improve our expertise in from the technical perspective as well.
All right. Okay. Next question we have from Yogesh Shinde. Anything for experienced people to learn and join? I'm into web development.
Sure. Like we always feel that there is again people think that I should have certain degree or certain courses under my belt so that I can get into particular domain. This is not very specific to data science, but let's say if you want to get into other domains as well, be it front end, back end, or testing, or any other thing, right? If you are willing to learn, if you want, if you can work in that domain, try to understand how it works from a technical perspective, from the business perspective, definitely you can get into that domain. So it's just matter of having the right mentoring or doing the self learning as well. That is fine. It doesn't matter whether you are working on the course. If you can get it done through course, it is good. But having the right guidance or getting the right path is very important in this aspect.
Sure.
Right.
Nick, can I add here?
For sure, yeah.
Yeah, so this is an interesting question, and Yogesh, in our existing team, we have a lot of people who are actually not from the technical background. So some of them are from business operations, some of them are from completely different backgrounds. So what Neil said is probably is about the mentality and then the hunger or the intent. So it all depends on that. Technology you can learn always. There are lots of materials, lots of blogs, videos available, but then yes, you can come from any background to Coditas and to data science vertical as well.
All right. Okay. Thank you, Sanket and Neil. Moving on to the next question. It is from Shubhi Malhotra asking, how many open positions do you have in the data department?
Very interesting question over there. So there are no definite numbers which we have in mind. If we have, I would say, if we have the right candidate with the right skill set and right mindset, they're always open. So keep on applying.
All right. Next question we have from Neha Kulkarni asking, can you please explain a bit about retraining a model?
Okay. Should I answer that, Neil?
Yeah.
Sure. Okay. Neha, so again, what happens is, let's say you train your model on last 2 years of data, okay, and then you deploy it. But then what happens is in this month or in the next month, you will always receive a new set of data. So it might happen that the model that you built on last 2 years might not run well after 2 or 3 months because it has seen, because it is trying to identify new patterns or new sets in data. So what happens is we try to train it or retrain it on the new set of data so that it gets aligned with all types of patterns and all types of the data sets that it has. So again, just to summarize, maybe you cannot have just one model deployed on production and keep it running on each new data. So you have to keep it retraining.
Okay, thank you.
Yeah,
Uh, can we move to the next?
sure.
Okay. Next question is from Sachin asking, can testers apply?
Yes, for sure.
Yeah.
Like answering the same question. So, if you are very much interested, be it from any domain, whether you are a designer, whether you are in any other domain, but if you have hunger to learn the right skill set which are required to be in this domain, then it doesn't matter what is your past history. It's always welcome if you have a right set of skill set in the particular domain.
Okay. All right. Next question we have from Arnav Desai asking how a data engineer finds patterns or dependency between different data columns to make a perfect structured data for ML model. Are there any good resources or example to understand this properly?
Okay, interesting question. So yes, I would say data engineers' work is about grabbing multiple sources from APIs, websites, CSV, Excels, or even on S3, and then getting that source or those all types of data files into at a common structure. So what happens is to build the pattern or to see the pattern, you need to first grab all type of data and then load it somewhere so that the downstream applications can use it. Now to talk about the resources, you can always learn SQL and Python. So data engineer would mostly do the PySpark coding or Python coding while they are on SQL as well. So the resources would be, there are tons of blogs, the YouTube channels are also there. So based on that, you can learn all the data engineering patterns and strategies. But then the whole and sole job is to grab data, keep it in a data warehouse type of solution so that it is available to the ML as well as the BI teams.
And there is no golden rule as such, like
Yeah.
where you can do work on three steps and you will be able to get the data in the right set of format. It depends for how many data sources you have, what kind of data you have, understanding the business patterns. So each use case, each client will come up with their own history, with their own technical expertise. So you have to focus from the start, from the base, understanding how the data is flowing. I think that is something which will help you to build the right data pipelines as a data engineer. That is the most crucial thing.
Okay, thank you very much. Next question we have from Rishabh asking what approach one should take if there is poor quality of data prior to working on ML model. Also, after the successful implementation, what if imperfections grow when data grows?
Okay. Neil, would you like to take it?
No, no, you can go ahead.
Okay, okay. So yes, Rishabh, what happens is, first of all, if there is bad data, as I said, 80, 70, 80% of the time goes into cleaning that data up. As an instance, if there are outliers, you need to handle them. There are missing values, you need to handle them. There are tons of features, you need to probably remove them. So there are various technologies and strategies using which you can handle the bad data. But yes, one thing is for sure, bad data impacts your ML model. So you need to handle it beforehand. Okay? You cannot pass the bad data to the ML model because it in turn will predict the bad things only. And then to answer your second question, what happens is, and that's where the retraining is important, because again, your ML model cannot keep on running on the trained data. So trained data was the defined 2 years historical data, let's say. So year on year, month on month, it will start getting new data. So it needs some retraining. It needs the learning again. So as soon as we have to find the impurities, the feedback loop that we talked about, we need to see whether the ML models are really helping business, and then based on that, we can apply some types of approaches wherein we can retrain the model, we can re-strategize our approach, and then based on that, the impurity can be removed from the model as well.
Correct. And as you correctly pointed out, right? So retraining the models, and if the right set of data you don't have it, right? So you can actually sit with the business that is there any other data sources from where you can get a much better data? Are there any different features you can basically use it, which can help you to build the ML models, and still you have bad data, then ideally you should not focus on like creating the models. The focus should be creating the right set of products which can actually enrich your data, through which you will create the data, and eventually it will be used by your models. So this will be the entire cycle which you need to follow, which might be tiring, which might be like very exhaustive process as a company, but the most important thing will be to capture the right set of data. So we based on our experience as well, right? So if the particular data is not getting captured is something which we should start doing it, so that over the period of time, let's say after 6 months or 12 months, you have the right set of data, then you can leverage ML or DL different techniques to create the right set of models.
Sorry. Yep. Thank you. Moving on, we have addressed this earlier, but maybe Neil, Sanket, you want to reiterate, because there are still people asking if we are hiring freshers. We have question from Himanshu, Neha asking the same again, that are we hiring freshers right now?
Yes, absolutely, absolutely. We are hiring. It's not about the experience bracket. It's not about your past experience. We just need the right mindset, probably Python SQL skills, right skill set, and then based on which you can apply. We are hiring across all the levels.
And the number of years of experience is a very outdated thing, right?
Yeah.
So now, like in this world, basically we should focus on having the right set of skill set, be it at 20-year old guy or 30-year old guy. So everyone's journey is different. If you have those skill set, then definitely there is a chance to have an opportunity at Coditas.
All right. Okay. Another question we have from Mahesh Chavan asking, can we start ML with Java? If yes, then how?
Yeah, so definitely we can start with Java. You can start ML with any language.
Yeah.
People in industry basically tend to use Python and basically R. The major reason is basically the packages which are built, the community which we have, right? The support which you will get is immense. So you would always try to you won't try to reinvent the wheel, right? So if the linear regression, let's say, is already built, there is already implementation is there in particular language. So we tend to go towards that. So that's the reason why in most of the cases you will see that people tend to go with Python or R in that case. But definitely the language is not a barrier, right? At the end of the day, these are mathematical equations which you solve.
Correct.
So in that way, but the overall execution time will get increased if you don't have actual implementation of those algorithms. So again, it's a trade-off which you will think from business perspective how the timelines are, and based on that we can take that decision.
All right. Okay. Thank you. And there are a few more questions. Maybe we can take this as the last question since we it's already past 8. Um, so the last question would be, what about data privacy in machine learning?
Absolutely love the question, Shivani over here. So it is becoming very critical in this era where that there's lots of tons of data, but it is getting misused or you don't know how you can secure it, right? So we actually at Coditas we make sure that the client data is secured enough. We basically I can't go into the actual detailed solutioning, but I can talk about we basically work with private clusters which we create, which can be actually utilized within that region where the client is working from, and only the secured gateways are open for the same. So this is just to summarize in a very short way. This is something which we are doing it, but this is a very crucial topic which we have the issue which we have in this industry, and it should be looked upon.
Right. Okay, so I think we can wrap up the question and answer session now. But if somebody still has any more questions unanswered, I'm sure they can reach out to both of you over LinkedIn and you'll be happy to answer them, right?
Sure, absolutely.
All right.
Definitely, yeah.
Thank you. Is there anything, Neil, Sanket, you want to say before I wrap up, or are we done?
I would just like to wrap it up in a way that thanks everyone for joining, and we are looking forward to connecting with each one of you because this is something which we share the love of data. So if you have any use cases or if you want to connect, that how we can help you guys from solutioning perspective, happy to connect with each one of you. And thanks again.
Yep. Thank you again. Thanks for joining. As Neil said, we are looking for more and more team members. So do join, do apply if you have, like as we said, right skill set, right mindset, and right intent. Also, please do reach out on LinkedIn if you have any question unanswered, and we would be happy to help.
Awesome. Thank you. Thank you very much, Neil and
Thank you,
Sanket,
everyone.
for this great session. Thank you. And thank you, audience, for joining us this evening. If you are looking for career opportunities, we at Coditas are hiring across verticals. You can check out our website for the same. And to specifically apply for data engineering and data science jobs that we discussed in this session, you can email your resume to Ruchika, who's the HR. The email ID is mentioned in the comments. Also, stay in touch with us on LinkedIn, Facebook, Instagram, and Twitter. We are very active on each of these platforms. Lastly, please share your feedback for this session, again, the link of which is mentioned in the comments. It will help us improve future experience for all of you. Thank you once again. Take care. Bye bye.